So the remainder of the time we have scheduled a panel session, and since I'm the only one who had any warning of this, I've managed to prepare some slides. Samson and Bart, wherever he is, would you like to come up and be my friend?
Let's see your slides first.
Yes. I'll show mine if you'll show me yours. I can't got my words. So I started out with just a couple of random sort of observations that have occurred to me while I've been listening to the talks. And one is the notion of distribution that's come up. And there are actually two distinct notions in the linguistics literature. And the notion that Ed had is kind of halfway between the two. So there's the notion associated with Zelig Harris, who was Chomsky's teacher, which is this, that you think you're a field linguist trying to figure out the syntax of a language that you don't understand. And you have a big corpus of examples. And in this corpus you notice that you not only do you find ABC, but you also find ADC in that corpus, and more generally observing that some sequence within a larger sequence can be replaced by something else suggests that they have the same distribution, as it were, so they're similar in some ways. So for example, Bob drinks beer on Fridays is a sentence in our corpus. Bob sleeps on Fridays is a sentence in our corpus, so that tells us that sleeps can replace drinks beer, and putatively therefore is the same kind of unit. We also notice that just Bob sleeps is in our corpus, so sleeps can be taken to replace sleeps on Fridays or drinks beer on Fridays, so that's a unit of the same kind. And that notion of distribution is meant to be more or less independent of meaning, in the sense that all you need is for the sequence to be in the language. It might not make sense, but people will still assent to it being a possible sentence of the language. So that's one notion of distribution. The other one mentioned by Steve in his talk on Friday is the one that's associated with Firth, what he calls actual words in habitual company. And his idea was that some aspects of the meaning of a word can be partly determined by seeing what it co-occurs with, and an example that he gives is a very British one somehow. One of the meanings of ass is its habitual collocation with an immediately preceding "you silly." Okay, so it's not the normal meaning of ass, but it's the one that is used to indicate that somebody is stupid. And that's quite independent of compositionality. In a sense, the Harris notion of distribution is the foundation for compositionality. It's what gives you the compositional structure of sentences, the syntactic compositional structure of sentences. And as has been said several times, that the semantics follow syntax in this way. Whereas the Firthian notion doesn't necessarily. So, for example, one of the words that collocates very, very frequently with the word work is hard, either as an adjective or as an adverb. So we get work hard, hard work. Now, those phrases do combine compositionally, but other examples, so doctor and nurse, have very high collocations in a corpus, but they very seldom occur maybe in a conjunction like doctors and nurses, but you don't get them in those kinds of structures. So they're two distinct notions, and the distribution, so-called distributional semantics literature has almost exclusively used this notion, and the reason for that is simply because it's easier. You know, you get more observations in a corpus of things occurring in a particular context, but correspondingly you'll get stuff that isn't necessarily guaranteed to say anything sensibly compositional about meanings. Okay, so that's one random observation. The second one is that we're looking for ways of combining vectors which we're getting from collocations at the moment, or moving a bit more towards the Harris notion, the sort of stuff that Ed was talking about, where we take grammatical relationships into account. But the kinds of compositional operations that we may need, I think, are not necessarily going to be just one-to-one with the syntax. So for example, Ed was talking about adjective-noun correlations. In fact, although the syntax of adjective-noun modification is fairly straightforward, the semantic consequences can be quite various depending on the semantic property of the adjective involved. So if we have something like this, Jan is a Dutch logician, Dutch is a so-called intersective adjective, so you can infer from that both that Jan is Dutch and Jan is a logician. And in that case, the semantic operation in terms of denotation is you take the set of Dutch things, you take the set of logicians, and you take the intersection. But relational adjectives like short don't behave the same way. So Jan is a short basketball player, doesn't imply, it implies that he's a basketball player, all right, but it doesn't imply that he's short, because even short basketball players are typically over 6 feet. So no, adjectives like this are always parameterized by a particular property. You can't isolate the set of short things, okay, because they'll actually turn out to be the set of tall things as well by some different measure. You might think, well, at least in both of these cases, whatever the noun property is implied, but there are adjectives that don't have that property either. So Jan is a lapsed Catholic. It doesn't even imply that he's a Catholic. In fact, for some people it implies that he's not a Catholic, although I don't think that's true. But certainly there are other adjectives that do behave like that. So a fake diamond certainly isn't a diamond, and a plastic gun isn't a gun. And it's quite difficult to see how counting vectors is going to give us those semantic properties, because pretty clearly if you have got a big enough corpus to get some non-trivial number of observations of phrases like Dutch logician, although in fact looking at most proceedings of linguistics conferences would give you quite a few observations. Right? It's pretty clear that the set of contexts in which Dutch logician occurs is going to be a subset of the set in which Dutch logician occurs, and the same is true for all of these. So the relationship between the counts and therefore the vectors is going to be the same for all three, but the semantic properties are quite different. Okay, that's another. Ed mentioned it's good to test, and I don't know whether it's deliberate, but all the examples of sentence similarity that people have given have been of sentences that are structurally isomorphic. So, you know, dogs chase cats, blah, blah, blah. I mean, in fact, a real test is to find something that isn't structurally isomorphic. So, if we can show that a noun phrase like a vegetarian comes out as very similar semantically to someone who doesn't eat meat, then I'd be very impressed. I would be less impressed if it also came out that carnivore was very similar to someone who does not eat meat, even though eating and meat and carnivore are very similar. So getting the logical words right is going to be interesting. Also, I think another test would be, can you capture similarity between relations with these examples that you often get in so-called intelligence tests. So the relationship between finger and hand is the same as, or very similar to that between toe and foot. It would be nice to be able to determine that. Whereas finger is to hand as cat is to mouse. Oh, it's weird. So that would be a good similarity relation, and that would be a bad example of similarity relations. So those are very challenging tests. That's all I have to say. I think Bart or Samson would like to make some points.
I could say one or two things. Not as specific as this about the, I mean, just from a wider perspective in terms of, I mean, because this is, the interesting point is this meeting is bringing a diverse collection of people together. And, I think it's been very interesting. I certainly like to see more of these kind of meetings in the future, more sort of interaction. So one thing that, one sort of general comment that struck me is that so I think even beyond the linguistics, natural language field, I mean, there's a sort of, I mean, one of the exciting things about some of the ideas we're seeing coming forward here is that one looks at the history of particularly artificial intelligence, is that there was a sort of primacy of logical methods in the first 2 or 3 decades, and then a sort of feeling that that hadn't worked so well, and a big move towards statistical methods, which have had successes certainly, but sort of a feeling that the time is right to sort of bring logic and structure back, but to combine it with the strength of the statistical methods. And I think what is very nice here is that we're seeing a sort of paradigm for how that could work, with a very nice underpinning mathematical structure, which is also interesting to some of the more theoretically minded people. So, and I think that, that one could even imagine involving a wider circle of people with broad interests of that kind, which would sort of further enrich this community. So that was one thought that occurred to me. I mean, one thinks of knowledge representation, machine learning, and wider issues. I mean, some of the work represented in the information systems group here, I can imagine such things might arise. I guess the other, I mean, thinking in terms of how to motivate work between these communities, I mean, I think there are clearly some very interesting challenges. I mean, the fact that there are these very concrete examples that are mathematically challenging, very concrete ways in which non-commutativity arises, which is always a challenge mathematically. It's kind of, whereas most of the examples in computer science beginning with monoidal categories have been, symmetric, and you can assume things are commutative, and that works pretty well by and large, with some exceptions to do with sort of things that are state sensitive and so on. But I think the very natural and compelling way that non-commutativity arises in natural language is sort of gives a very well motivated challenge to look at these more general settings. So I think that could also serve to motivate people coming from the more theoretical end to be involved in this activity. And anyway, as I say, I would personally hope to see further meetings of this kind, and further interaction, more detailed ones between these communities. That's mostly what I wanted to say.
Yes, well, my impression is that there are roughly 3 communities here: the linguists, the quantum people, and people from the co-algebra community. You see that quantum is sort of in the middle there when it comes to connections to these areas. There are obvious connections we've seen between quantum foundations and linguistics when it comes to information flow, but also which is underpinned by this idea of plugging things in a certain way, resulting in specific flows and manipulations of these flows. Also, there are connections between this quantum world and co-algebra from the perspective of state-based computation and transitions and observations. Although it's still in an early stage, I think that's a fruitful area where things will be happening the next few years. I don't see any immediate connections between linguistics and co-algebra. It's not necessary that there are such connections. But possibly you see certain things there are, but when you're looking for such connections, it's good to ask the question: is there any state-based manipulation involved? And probably you linguists know better than I do if there is. I can imagine. I mean, the way you analyze syntaxes and the way you use such a corpus. As a way to interpret sentences. You can see the corpus as a state, but somehow it seems to be a state that is not influenced, not changed by the analysis. You could imagine that you have some sort of feedback that the corpus itself is continuously improving by the further analysis that you carry out. That is a possible approach. But again, I'm an outsider here. Well, what I see of this meeting is that these communities did their best to present their own work and try and present some connections, but I think the real work still has to be done in specific areas, and maybe it's useful for the next meeting to focus focus a bit more on really trying to elaborate these connections, and not so much a one-way presentation as it was here. Maybe that should be done for a smaller community. My own experience is in getting different communities to work together is that a top-down approach doesn't work, but bottom-up approach may work, but then it's very useful to have a few specific examples that are appealing to several communities, and that you work from these examples and then discuss them jointly. So what does it mean when you say this for this example? And then things become more complete and often more useful. So it might be interesting to try and develop both a set of common examples that people can work on, or even more ambitiously a set of open problems. So if you have feedback on this.
What is an example of a common example?
What is an example of a common example? I guess this is a question to everyone, not so much to me.
We can work on it for the next minute.
I comment about your Harris and Firth comparison, which was really interesting. It's not obvious to me that what Ed was doing was Harris necessarily, in the sense that I still think of it as being Firthian, but the way in which you define context is via these dependency relations. So.
It's certainly not the same as Harris, but it is making sure that things bear some syntactic relationship to each other.
But it struck me that there's another question that comes out of that comparison, which is to what extent you can try and learn the compositionality. So the way it's been presented so far is that we start out with these vectors that are obtained in some way, and then the compositional structure comes entirely through the theoretical framework. But then there's this other question whether you can try and learn some of that compositional structure automatically as well. So that's what you're thinking about a little bit more, isn't it? What you do is learning the compositional structure a little bit more than an alpha.
So you're learning about such things as verbs and adverbs and so on, and what types they have. Is that
More in the way in which things combine.
Yeah, so
beyond that.
So for example, the kind of problem that Pulman was talking about, where fake gun isn't a gun kind of thing. So how do you learn that automatically from the corpus?
Well, the song is learning things. People keep using the word learning.
Oh, what learning means?
Trying to get something from a corpus.
Yeah, just getting it from data.
Automatically getting it from a corpus.
Yeah, that's all. As in machine learning, it's
So
just a generic term.
You can kind of think of these vectors we've got as learning the meaning in a sense.
Oh, just because they come automatically from the data, that's all. It doesn't mean anything more than that in this context.
What I find the interesting challenge is a bit in line with what Samson was saying, this combination of logic and probability, which I think is really a challenge and underlying what's happening here, and would be useful to have good formal descriptions of what are, I guess, also state-based systems on which you can do observations with certain whose outcome has certain probabilities, and these as dynamical systems where these probabilities get updated as you continue to work with these kind of systems. And for me, it's a sort of long time question, or maybe I should say in a Buddhist way, a koan. And what is a quantum topos? What is something similar to a topos, but involves, in a suitable sense, both this logic of predicates and probability on these predicates in a suitable mathematical structure.
Yeah, I mean, but what I think I'd just sort of say to add a twist to that is that I think there's been a lot of work in semantics and coalgebra and other approaches on semantics of probabilistic computation or verification of probabilistic programs. But here's a different thing where we're thinking of really of sort of statistical data and using that for inference.
Yeah.
You get to the whole machine learning paradigm and so on. But it may not be, I mean, maybe some of the tools that we have developed could be used in that direction. I think that has a lot of potential. That's what I was trying to say earlier, because, you know, bringing the two things together, I think potentially very powerful. We've seen some of that.
Yeah. Yeah, and what is interesting, at least to me, is this subtle combination of syntax and semantics that's involved. Your semantical, or your knowledge drives your interpretation of the syntax. You had some examples of seeing the man with the telescope, where some background knowledge determines also your syntactical analysis. I think that's also very interesting.
There's another useful distinction to be made, which is that we're talking generally about statistical methods. But actually, when people talk about distributional methods, there isn't really a notion of probability there. It's just this geometrical vector space method. So I think there's another question which maybe we could take ideas from theoretical physics, because my understanding there is that there's a very tight relation between probability and what a vector is in a Hilbert space or something like that. But we haven't really explored that question in computational linguistics.
Yeah.
So there's all this statistical work which is somewhat separate from the distributional models that people have been talking about. So it'd be nice to put those together as well.
Okay.
Maybe the statistical physics actually offers a better paradigm. We really have mass data. I mean, the thing with quantum is that even a single system has probabilities associated with it.
Yeah.
But I think
I have to leave at 1.
Yeah.
Or 2 was that?
Precisely.
Okay, well I think we've, it's probably time for lunch. Well, I'd like to thank Manoush and Chris for organising, the collaborators for organising this workshop, and for everybody who's spoken, and for people who are coming along. It's been really sort of enjoyable and fruitful, if occasionally baffling experience. Thanks very much.